Hello viewers, in today's session we are going to discuss the domain of this function f of x, which is equal to square root of natural log of x and square root of 1 minus x square. So here f of x is given as a sum of two functions, right? So let us call this function as say h of x, and let us take this function as g of x, right? So here f of x is equal to the sum of the functions h of x and g of x. So in order to find out the domain of this function f of x, what we will do, we'll first find out the domain of this function h of x, and let us consider the domain of this function h of x as d1, and the domain of this function as d2, right? So here the domain of this function f of x may be taken as d. So d is the intersection of the domain of h of x and g of x, right? So d is the intersection of d1 and d2. So here we'll consider all the values of x in the domain of this function f of x, which are common to the domain of h of x and the domain of g of x, right? So let us start. So now let us first find out the domain of h of x. Now here inside the square root sign we have natural log of x, right? So the first condition is that this x has to be greater than 0, and x cannot take the value 0, because a logarithm of 0, it tends to minus infinity, right? So here the first condition is that this x should be positive, that is x should be greater than 0 and x is not equal to 0. And the second condition is that this entire term, that is logarithm of x to the base e, should be greater than or equal to 0, because here inside the square root sign we cannot have uh, a negative quantity, because if we have a negative quantity inside the square root sign, then we have the complex number, right? So this term, that is logarithm of x to the base e, has to be greater than 0 or equal to 0, and x should be greater than 0, and x cannot be equal to 0, right? So now let us solve this inequality, that is logarithm of x to the base e is greater than or equal to 0. So from here we can write, or we can raise these two terms to the power of e. So we have e raised to logarithm of x to the base e, and here we have e raised to 0. So raising these two quantities to the power of e, right? And here the direction of the inequality remains the same, because log x to the base e is an increasing function, right? So here we have now simply x, because we know that e raised to logarithm of x to the base e is equal to x, right? And here we have e raised to 0 is equal to 1. So here we have a 1. So the domain of this function h of x is given by all values of x which are greater than or equal to 1, or we can write x belonging to the interval that is 1 to infinity. So here 1 is included. So this is the domain of this function h of x. So now let us find out the domain of this function g of x. Now here inside the square root sign we have 1 minus x square, and again we have 1 minus x square should be a positive quantity, that is it should be greater than or equal to 0. So here we cannot accept those values of x which makes 1 minus x square equal to some negative number, because if we have square root of some negative number, then it belongs to the set of complex numbers, and here we are dealing with the set of real numbers, right? So the domain of this function g of x is defined for all values of x for which 1 minus x square is greater than or equal to 0. So from here we can now write x square greater than or equal to minus 1, taking this one to this side, and then multiplying both sides by negative 1. We have here x square and here we have 1. So this becomes positive, this also becomes positive, and the direction of the inequality, it get reversed. So now we have x square less than or equal to 1, and this can also be written as 1 square. So 1 is equal to 1 square. So now here we have the inequality of this type, that is x square is less than or equal to say a square, right? And the solution of this type of inequality is given by x greater than or equal to minus a and less than or equal to positive a, or x belongs to the interval minus a to a. So here the value of a is 1. So we have x belonging to the interval minus 1 to 1. So this is the domain of this function g of x. So now let us represent these two domains d1 and d2 on the real number line. So here we have minus infinity, here we have plus infinity. Now here we have say minus 1 and here we have 1, right? So the domain d1 is from 1 to infinity, that is 1 is also included, right? So here we have the dark circle which represents that 1 is also included, right? So here we have this region, that is d1, that is from 1 to infinity where 1 is included, and here in d2 we have the interval from minus 1 to 1 where both the endpoints are also included. So here we have minus 1 and here we have 1, right? So here we have the dark circle, that is which indicates that minus 1 is also included, and here we have 1. So we have this region, that is d2, right? So now the domain of this function f of x, which is d, is the intersection of these two intervals or these two domains d1 and d2. So now we can write d as here d1 is 1 to infinity, and here we have the intersection, and then we have a d2, that is minus 1 to 1. So now we have to identify the common values of x which belongs to these two intervals, and from this representation we can easily identify the point, that is 1 is the only point which belongs to both the domains, that is d1 and d2, right? So d1 is from 1 to infinity and d2 is from minus 1 to 1. So 1 is the only common point or the intersection of d1 and d2 which constitutes the domain of this function f of x, right? So d, it comprises of only one point, that is x is equal to 1. So here we have 1. So the domain of this function f of x is given by only one value of x, that is equal to 1. So 1 is the or x is equal to 1 is the only value which is in the domain of this function f of x. So this set, which is a singleton set, that is having only one element. So this singleton set represents the domain of this function f of x. Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions, and here we are going to find out the domain of this function f of x, that is equal to square root of natural log of x minus 1 plus 2 times sine inverse x minus 2, right? So here we are going to make use of the concept of intersection of domains, right? Now see, here f of x is the sum of these two functions. So let us take this function as g of x, and let us take this function as h of x. So g of x is our function square root of natural log of x minus 1, and h of x is 2 times sine inverse x minus 2, right? So here what we will do, we'll first find out the domain of this function g of x, which is square root of natural log of x minus 1, and let us call the domain of g of x as d1, and then we'll find out the domain of this function 2 times sine inverse x minus 2, and let us call the domain of this function as d2, and let us call the domain of f of x as d. So here the domain of this function f of x is the intersection of the domains d1 and d2. That is, this function f of x is defined for only those values of x which are common to the functions, or common to the domain of the functions g of x and h of x. So first we'll find the domain of g of x, which is d1, then we'll find out the domain of h of x, which is d2, and then we'll take the intersection of these two domains to get the domain of the function f of x. So let us first find out d1. So now here in the function g of x, we have natural log of x minus 1 inside this square root sign, right? So here g of x is defined for all values of x for which natural log of x minus 1 is greater than or equal to 0, because this term, that is natural log of x minus 1, it has to be greater than 0 or equal to 0, because anything which is negative inside the square root sign is not defined in the set of real numbers, right? So natural log of x minus 1, it should be greater than or equal to 0. And moreover here x minus 1 should be greater than 0, because x minus 1 should be a positive number, so that natural log of x minus 1 is defined in the set of real numbers, right? Because natural log of negative numbers are not defined in the set of real numbers. So here the additional condition is that x minus 1 should be greater than 0, and obviously x should not be equal to 1, because when x is equal to 1, then we have natural log of 0. 1 minus 1 is 0, and when x tends to 1, then a natural log of 0, it tends to negative infinity, right? So the domain of g of x is given by this condition, that is natural log of x minus 1 is greater than or equal to 0, along with x minus 1 is greater than 0 and x is not equal to 1. So now we have to solve this inequality to get the values of x, right? So what we will do here, we'll raise both these quantities to the power of e, right? So we can now write e raised to natural log of x minus 1, and here we have e raised to 0. Now see, here we can also write this inequality as logarithm of x minus 1. Here we have the base e, and here we have greater than or equal to 0, right? So natural log of x minus 1 is greater than and equal to 0. So raising both these numbers to the power of e. Now here we have to make use of this uh, identity, or this result, that is e raised to natural log of p is equal to p, right? So here we have simply x minus 1, because for p we have x minus 1, and here we have e raised to 0, that is equal to 1. So now taking 1 minus 1 to this side, we have x greater than or equal to 1 plus 1. So we have x greater than or equal to 2, right? So the domain of g of x is given by x greater than or equal to 2, or x belonging to the interval 2 to infinity, right? So this is the domain of uh, g of x. So now let us find out d2, the domain of h of x. So now here we have the inverse sine function, right? And we know that the principal value branch of say sine inverse theta, it belongs to the interval that is minus pi by 2 to pi by 2, provided theta belongs to the interval minus 1 to 1, or we can write theta greater than or equal to minus 1 and less than or equal to 1. So sine inverse theta has the principal value branch, that is the range is minus pi by 2 to pi by 2, where both these endpoints are included, and provided this theta, it belongs to this interval minus 1 to 1, or this inequality. So now here we have 2 times sine inverse x minus 2. So let us consider only sine inverse x minus 2. So now if we compare this expression with this one, then theta is equal to x minus 2. So let us now substitute theta is equal to x minus 2 in this inequality, right? So we have minus 1, then we have x minus 2, then we have 1, right? Now adding 2 to throughout this inequality, we have now here minus 1 plus 2, then here x minus 2 plus 2, and here we have 1 plus 2. So 2 minus 1 is 1, here 2 and minus 2 get cancelled, and here we have 1 plus 2 is 3, right? So the domain of this function h of x is given by this inequality: x is greater than or equal to 1, less than or equal to 3, or we can also write x belonging to the interval 1 to 3, right? So now we have the domains d1 and d2. So let us now represent these two domains on the real number line. So here we have the real number line, here we have minus infinity, here we have plus infinity, and here we have the point 1, here we have 2, and here we have 3. So now d1 is given by this interval 2 to infinity. So here 2 is included. So here we'll draw a dark circle, and here we have 2 to infinity, so we have this region, right? So this region represents a d1, that is 2 to infinity, 2 is included, right? And d2 is given by this interval 1 to 3, right? And here 1 and 3 are also included, the extreme points are also included. So here we have 1, here we have 3, right? So we have this region, right? So now we have to identify the common region, which gives us the domain of the function f of x, because d, that is the domain of f of x, is the intersection of d1 and d2. d1 is 2 to infinity, and then we have the intersection, and here we have 1 2 3, right? So we can easily see from this representation that this region, that is this region, is common to both the domains, right? So this is the intersection of d1 and d2, and d, which is the domain of f of x, is given by this interval, that is 2 to 3, because this part is common to both the domains, that is d1 and d2, right? And here it is important to note that 2 is also included and 3 is also included. So the required domain of f of x is given by this closed interval 2 to 3. So this interval can also be represented like this, that is x is greater than or equal to 2 but less than or equal to 3. So the domain of this function f of x, which is the sum of these two functions, is given by this closed interval 2 to 3, or x greater than or equal to 2 but less than or equal to 3.